Hi everyone, welcome to today's webinar on the dangers of sodium azide. We'll be covering health effects, handling, disposal, and more. My name is James, I'm the webinar event coordinator at Triumvirate, and I'll be your moderator for today's event. Before we get started, I'd like to give you a brief overview on what the webinar is going to entail as we run through a few housekeeping items. Please note that all lines will be muted, so your microphones will be turned off, but you can ask a question or let us know if a technical issue comes up by using the questions pane on the right-hand side of your screen. Following the presentation, there will be an open Q&A period. The presentation should go about 40 minutes, and then we'll spend the remainder of the session for questions. Any unanswered questions will be followed up on after the webinar in the coming days. And most importantly, keep in mind you will receive a copy of the slide deck and the webinar recording, so you can view this at your convenience at a later date. I'm pleased to introduce our speaker today, Ryan Miller. Ryan is an engineering project manager at Triumvirate Environmental, where he's conducted numerous environmental engineering projects and remedial response actions. This includes tank removals and closure reports, lab and facility decontaminations, hazardous building materials identification, and sodium azide remediation. Mr. Miller has also carried out engineering consulting services, remedial system operation and maintenance, building material inspections, and spill response work throughout his career. He has a BS in environmental engineering from the University of New Hampshire. So now I'll turn things over to Ryan. Hey, Ryan.
Hey, welcome everybody. Just a little bit more about my background as it pertains to sodium azide. I was a lab pack chemist when I started here at Triumvirate about 8 years ago. So I have experience with performing lab packs with sodium azide, virgin sodium azide, also sodium azide in solution. After that, I started moving into the engineering role, and we've done wipe sampling for sodium azide after lab is decontaminated. We'll go through, decontaminate the lab, and do wipe samples to ensure that sodium azide has been removed. That's a laboratory analysis that can be performed. And I've also had experience with remediation of sodium azide in laboratory waste piping after, unfortunately, explosions have happened at some of our clients' sites where metal azides have formed, and subsequent work on those pipes resulted in explosions. We've gone in and remediated the rest of the system to prevent that from happening again. And we'll talk about all that today and hopefully get to know sodium azide a little bit better and answer any questions that anybody might have at the end. So the agenda for this webinar, we'll start out with a background, get into handling, storage, and disposal. I'll talk about that sodium azide remediation, and then we'll end with a summary and Q&A. So, first off, what is sodium azide? You can see there, chemical formula NaN3. You have a sodium atom with 3 nitrogen atoms. Azides are sometimes referred to as high nitrogen energetic materials. That's just based on this chemical formula. So the nitrogen bonded with another nitrogen atom is actually one of the most stable molecules. The electrons form a strong triple bond. And the strength of this bond means that when 2 nitrogen atoms snap together, they release lots of energy. So this formula pretty much has readiness to display suitable leaving groups, which would make it potentially energetic in the right sort of reaction. Its physical properties, it's inorganic, odorless, colorless salt, and is very acutely toxic in its purest form and can be explosive in the right conditions. So another important chemical product of sodium azide and other azides is its solubility. So if you look at this chart, you can see that sodium azide, which everybody's mostly familiar with, has a high solubility, 40.8 grams per 100 milliliters of water. So that's pretty readily soluble. But if you look towards the bottom, things like lead azide, which you would find in a laboratory waste piping that would be contaminated just because of the lead that's in some of the fittings of the piping, You see that that only has a solubility of 0.0249 grams per 100 milliliters of water. So that's quite the difference when you have something in its purest form like sodium azide in relation to something like lead or silver azide. And that'll be important when we talk about remediation. So available toxicity data for common azides. Toxicity data only exists for sodium azide at an LD50 of 27 milligrams per kilogram. The only other azides that they have toxicity data for is ammonium azide and barium azide, which is only defined as very toxic and toxic. And it's a loose definition that basically just says these substances may cause significant harm or even death in very small amounts through various routes of entry. So more about the health effects. Ingestion of even a small concentration can be fatal. The seriousness of poisoning really just depends on the amount, the route of entry, and the length of exposure. But exposure is defined as small amount can lead to coughing, dizziness, headache, nausea, vomiting, rapid breathing, rapid heart rate, red eyes, weakness, and skin burns. But exposure to a large amount leads to convulsions, low blood pressure, loss of consciousness, lung injury, respiratory failure, slow heart rate, and death. A lot of people kind of compare sodium azide poisoning to that of cyanide poisoning. And even though they're different chemicals, for both the chemicals, the routes of entry can be the same. So it can be ingested, inhaled, or absorbed. And once it's within the body, both react similarly as they interfere with cells' ability to use oxygen. So that leads to similar symptoms and can lead to death. So they're kind of thought of in the same light. And with that, the CDC has no specific antidote for sodium azide entering the body, but literary medical studies had treatment for sodium azide, the same treatment that they would give somebody for cyanide poisoning. And that treatment includes amyl nitrite inhalation followed by intravenous administration of sodium nitrite and sodium thiosulfate. And the studies show that this had mixed results. Sometimes it worked, sometimes it didn't. So right now, there's no specific antidote, and the efficiency of treatment is still yet to be determined. So that's why it's something that's very poisonous if entered the body. Another thing to note is that mixing with water or acid creates toxic hydrozoic gas. If you mix it with just water, that hydrozoic acid and gas concentration is actually very low. Probably not even enough to cause any of these symptoms, maybe weakly. But if you were to mix it with a strong acid, like sulfuric, then you would have that reaction be much more violent, and you would see this hydrozoic gas. And also, something to note is contact with transition metals can lead to the formation of explosive and shock-sensitive metal azides, and that's what I had alluded to with the laboratory waste piping. That's where that danger comes in. So where is it used? Not everybody knows. Some people might know this, but sodium azide is actually used as the propellant in airbags to the chemical reaction. The heating of the sodium azide generates a reaction that produces metallic sodium and nitrogen gas. And it only takes about 130 grams of the sodium azide to be ignited to produce enough gas to fill an airbag, which is about 67 liters. And this reaction, if you've ever seen an airbag go off, it's extremely fast. It only takes about 30 milliseconds for an airbag to inflate. And the design is designed so that when somebody hits the airbag's already been fully inflated and is actually deflating to create that cushion. So some people might be thinking, well, if sodium's a byproduct, isn't that toxic also? It is by itself, but there are inert materials that are put in there as well to react with that sodium. It's essentially sand, so that sodium reacts with the sand to create a less hazardous byproduct. Sodium azide has been superseded by less toxic material. A lot of manufacturers switched because of complaints about the toxicity. Some use ammonium nitrate, but that has caused some problems with airbags. If you recall, there's been a lot of actual recalls on airbags just due to that fact that some of them were exploding too violently and releasing debris into cabins and causing all sorts of trouble. But getting back to sodium azide, it's also used as a preservative. It's used in pesticides. It's toxic to most organisms and blocks the cytochrome electron transport system, so it makes it an effective pesticide or mutagen, as well as a chemical probe. It allows chemists to chemically probe by rapidly and reversibly inhibiting a protein or protein domain cells, so that's how it's used in research. You can also find sodium azide solutions in automated hematology equipment or blood counters. These pieces of equipment utilize sodium azide solutions for its properties of being a preservative. And a lot of these companies that produce these recommend drain waste disposal, and they define it as copious amounts of water. We'll get into that a little bit, actually the next slide, but copious amounts of water is pretty loosely defined. To really be successful, you have to flush these systems, or the piping system, with 100-fold excess water for every drop of solution that's going in there. Even if it's at 0.01% sodium azide in that solution, if this thing's constantly dumping waste into the system, over time that sodium azide is going to react, if the plumbing is metal, to form those other insoluble metal azides. So that's something to watch out for, and we'll get into that more now. In October of 2013, Instrumentation Laboratory and Orphan Group released a notification for their IL hematosis system, and I highlighted some important things on this. And it says that this notification is intended to reinforce that the waste from your IL hematosis system contains sodium azide that may potentially form explosives in metal plumbing composed of lead, brass, tin, copper, or zinc, or containing solder in the plumbing system, and to emphasize that good work practices should be followed to mitigate the risk of explosion. So when sodium azide preservative in reagents is disposed down the drain, it can react with the metals in the plumbing to form insoluble metallic azides. These metallic azides are highly explosive. Metallic azides may explode if subjected to friction, heat, shock, or by reaction with other chemicals. So that's pretty heavy when the recommendation is to put this down the drain with copious amounts of water. A couple of our clients actually received this notification, and we went in and performed a assessment to see where the hazards, if and where the hazards were present, and it's around a lot more than people think, because of that drain disposal. It's so common for these hematology equipment. So this is just a photo of one of the experiences that I've had with sodium azide being discharged into a drain system. You can see that that's the effluent of the machine just going into the sink. And then that's a photograph from underneath the sink. This was actually at a client site where an explosion had happened. Excuse me. And you can see that in the tail end of the sink and the sink trap, there's quite a bit of accumulation of what appears to be salts, and just doesn't look good. There's a reaction going on there. And at this particular site, one of the plumbers came in. There was a leak in a system that looked similar to this. And he removed the tailing. He removed it, no problem. And it had the fitting on there, which was a brass fitting. And he brought it down to his maintenance area, and he set it on the table where it sat for a couple of days and was allowed to dry out before he went to pick it up and move it to a metal recycling bin. That's when the metal azide reacted, and it blew up in his hand, caused shrapnel to enter his hand, caused ear damage and psychological trauma just from quite a surprise to pick up that tailing piece of pipe and have it blow up in your hand unexpectedly. So it was a big deal. I talked with the guy after when we had gone up to do our remediation, and he was back to work. Luckily, he had healed and had multiple surgeries. But this is definitely a hazard, and it definitely affects, you know, plumbers and maintenance people that maybe aren't aware of everything that's going on in a lab, especially discharge like this of sodium azide when there is that potential. So that's just a little background, sodium azide, what we're going to cover today. Another important thing to note is just handling, storage, and disposal. So we'll get into that right now. So a warning from the FDA came out in early 2015 because the FDA had actually received an increasing number of explosions involving solutions containing sodium azide, where it's used in clinical facilities, which we just talked about. The communication was published to the FDA website, reminding laboratories and hospitals about the danger posed by long-term accumulation of sodium azide solutions and recommended steps to prevent such incidents. One of the incidents I just talked about, where that pipe had exploded. Another incident was when an explosion occurred when workers were attempting to remove copper ground wire that wasn't even part of the plumbing system. It was just in the vicinity of one of those pieces of equipment, and over time the thing was leaking and it was coming in contact with that copper ground wire and actually formed copper azides, and when they went to do work on that, the same sort of incident happened where it blew up. And talking to people where this actually happened to them, you know, I really wanted to find out everything I could, and they described it as something similar to like a .22 caliber bullet being shot. If you can relate to that, it's kind of just a loud, quick pop, but that force is enough to release shrapnel from copper. It's enough to really cause psychological trauma and also ear damage and other skin damage. As far as this picture goes, this was an explosion. I didn't take this. This is from the internet, but this was from an explosion at a university where a graduate student had 200 grams of sodium azide. The experiment that he was performing involved the use of sodium azide and polyethylene glycol, and he was trying to make trimethylsilyl azide. And this unfortunately happened when there was personnel in the lab. They think that he just heated up the sodium azide too quickly, and obviously if it's used in airbags, you're going to get a good explosion if you heat it up. And overheating caused injuries such as second-degree burns, cuts requiring stitches, debris in the eyes, glass injuries, eardrum injuries, and psychological trauma. So with that, we'll go into recommendations for proper handling, storage, and disposal. So sodium azide handling, obviously you always want to use proper personal protective equipment such as gloves and eye protection. When handling sodium azide or sodium azide solutions, you want to avoid contact with acids or heavy metals, especially where there is potential for sodium azide to become concentrated, such as reagent waste areas. Avoid touching or replacing corroded materials if the corrosion may be due to sodium azide. If you do observe corrosion on metals, copper, or anything, where sodium azide is in use, it's recommended to contact the manufacturer or contact Triumvirate. We can come take a look. We have experience in this, and we can help. Also, avoid exposure to potentially concentrated sodium azide to friction or shock, because it is shock sensitive. Other recommendations, do not store tubing or other materials that may have been in contact with solutions containing sodium azide. If that solution is able to dry out, you can have dry sodium azide salts, which exhibit high toxicity and potentially energetic properties. Collect sodium azide waste in a plastic reservoir and label the container with a proper name. That's the best way to dispose of this, in my opinion. And clearly label all medical devices, collection containers, and waste disposal fixtures that use products containing sodium azide. And that's just, again, to make people that might not be aware of the hazard that enter lab spaces or enter clinical areas of that hazard, the toxicity and the potential for explosions. Sodium azide disposal. Obviously follow local, state, and federal regulations regarding handling and disposal of hazardous waste, including potentially explosive materials that have accumulated or concentrated sodium or metal azides. Just keep that in mind about materials and building materials around the lab. Dispose of solutions per instrument and analyzer label instructions. Keep in mind what I discussed earlier, that the implications of your laboratory waste piping or improper flushing can result in a hazard, even by following those manufacturer instructions. Again, a lot of times it's just labeled as copious amounts of water. You can see at the bottom, flush sodium azide solutions with at least 100-fold excess of water. It's often recommended, but it poses a problem down the road if you do have metal components in your plumbing. So the Clean Water Act actually allows for disposal in sanitary sewer systems if the concentration is less than 1% of the total annual wastewater from the facility. And if you're using hematology equipment that only has 0.01% sodium azide in it, it's easy to say that that's achievable. But at the same time, when you have the manufacturers for these hematology equipments and the FDA and CDC bringing out warnings about that danger of drain disposal, it's a good thing to keep in mind. Moving on to lab pack waste. So Triumvirate's experienced lab pack chemists can safely remove unused or unused sodium azide from your labs. I've done it. I know everybody that's in our chemist program knows the dangers of it. If it's present in your labs and it's no longer used, you may want to consider removing it from the lab completely. Removing it now can prevent any sort of health and safety issues in the future because of its toxic properties and potential for explosions, its energetic properties. So something to keep in mind with that is virgin product is considered P-listed waste or acutely hazardous waste. So this will affect your generator status if you have it and you're anything but an LQG. An LQG, or a large quantity generator, generates more than 2,200 pounds of hazardous waste per month and is allowed greater than 2.2 pounds per calendar month, where SQGs, or small quantity generators, generate less than 2,200 pounds per month and cannot accumulate greater than 2.2 pounds at any time. CSQGs are conditionally exempt small quantity generators, or in Massachusetts, very small quantity generators can't accumulate any in Mass, where CSQGs cannot accumulate in greater than 2.2 pounds at any time. So if you do find yourself in possession of virgin sodium azide and you are, say, a VSQG or a CESQG, or even an SQG, and you think your generator status has to change, that can happen. It can be made, changes can be made to accommodate a shipment to get rid of this. So it's something to keep in mind, but it's not a deal breaker when it comes to removing virgin sodium azide. So moving on, we're going to talk about sodium azide remediation. It's one of the better topics, I think, just because it's not widely known of how this has to be treated. But NIOSH actually published facts about sodium azide, including the fact that over a period of time, azide solutions discharged into laboratory wastewater piping reacts with copper, lead, and brass or solder to form an accumulation of lead or copper azides, which I explained are shock sensitive and explosive. The warning that came out from NIOSH basically said that this chemical reaction that forms lead azide is a more sensitive primary explosive than nitroglycerin, and it's actually one of the most effective detonating agents known, but because of its instability, it's just too sensitive to be used commercially. So that's something to keep in mind about how energetic this stuff is and the hazard behind it. So with that, NIOSH and the CDC published decontamination procedures for azide contaminated plumbing, and we'll get into that now. So these are photos that I took at one of our remediation sites. Basically, the first step is to inspect the plumbing and figure out where the potential for metal azide contamination is present. That first photo on the left shows where we found the straight lab pipe had changed to PVC. The local sink drain system was all of the copper and brass fittings. So we were able to cut and isolate that area where the potential contamination could have been. And after that's done, according to the NIOSH and CDC plan, a 10% sodium hydroxide solution is administered to the system. You can see our technician doing it there. And that solution is allowed to soak in the isolated system for 16 hours. And that soak is basically corroding the copper and breaking down any organic material. And by breaking down the organic material and penetrating the interstitial space of that piping between the fitting and the piping, you have threads. In those threads is the most likely place that you're going to have metal azide buildup, just because of how the water flows through the system. Once it hits that copper or brass fitting, the water continues through the system, but those little drops that keep hitting constantly is going to start a buildup of sodium azide, which will then react with the metal to form the metal azide. So this initial step is to break anything down in those interstitial spaces and kind of loosen up anything in the system. That's why we monitor it for 16 hours. Following that step, the solution is collected and the system is rinsed for a minimum of 15 minutes with water, just to get it flushed and ready for the next step. As you can see here, each workspace is contained and the gases are vented during the entire process. Nitrous gas is monitored in the space using a Drager pump and detection tubes, just to make sure anybody in the area isn't getting affected. We tend to do this work off hours, but most hospitals have a skeleton crew running all the time in those off hours. So we just want to make sure everybody's safe, so we're doing gas monitoring and venting during the whole process. So once that system is flushed with water, a nitrous acid solution containing 20% acetic acid and 20% sodium nitrite is added to the system and allowed to soak for 24 hours. You can see from these photos that nitrous acid has a distinct greenish blue color. It's pretty unstable, and it decomposes quickly in solution to nitrogen dioxide, nitric oxide, and water. When it breaks down into that nitrogen dioxide, you actually see a brown-red gas, which is the nitrogen dioxide, that comes up, emits quickly once this is mixed and introduced to the system. That's why it's important that we have everything vented and contained so nobody gets exposed to that. And once that solution's in the system, it's allowed to soak for 24 hours. And this acid is introduced to actually solubilize and destroy sodium and metal azides in the plumbing system. That system, or that acid, at the same time is doing what the sodium hydroxide did. It's breaking down some of the components of that metal to allow it to get into those interstitial spaces. And as a result, if you look to the right, you get leaks in the system. So any sort of clean outs or areas where there's fittings, those start to leak over time. So we have personnel on site with secondary containment collecting that the leaks and then reintroducing fresh acid into the system as needed to keep it full and make sure that the acid is coming into contact with all the metals that we're looking to decontaminate. After that, it's another 15-minute flush just to prevent any sort of corrosion contact hazard for that metal, because pretty much after that whole long process, the metal is now scrap. It's free. We do an inspection of crystals, so we make sure it's free of salts or crystals or any sort of visual contamination, and it's cleared for removal. And when we do removal, Triumvirate personnel do don explosion-proof PPE just as an extra precautionary measure, just in case, just to make sure that there's no explosions during the initial breaking of those fittings or the system. And then, like I said, a visual inspection is conducted, and that metal is considered non-hazardous. So here's just a few more photos. Again, isolation of the system shown on the left. Introduce sodium hydroxide, 10% sodium hydroxide to the system. Allow that 16 hours, soak, rinse, do the nitrous acid for 24 hours, venting the whole time, monitoring for gases, then another rinse followed by removal. So each one of those waste streams is collected individually, because if we were to mix them, we would have a pretty serious reaction with sodium hydroxide and nitrous acid. So we collect each one individually into DOT-approved containers, label it as needed, manifest it, and get it out. So we do a complete waste removal of the sodium azide remediation waste after the work is performed. So we'll have a brief summary, and then we'll get into Q&A. In summary, sodium azide, it's extremely toxic and potentially explosive. There's a couple different things that can lead to explosions: heating it, mixing it with strong acid, or coming in contact with transition metals, or even abrupt friction or shock can lead to sodium azide exploding. Discharge of sodium azide solutions into plumbing containing metals leads to potential explosions. Any amount of this material, we've seen it happen at client sites, like I said, where the solution is only 0.01%. But over time, in those areas, this solution builds up and it leads to a definite potential hazard. So remediation of contaminated plumbing is possible. We utilize the procedure that was prescribed by the CDC and NIOSH, and we've been successful with it, and it works. So with that, I'll turn it over to James.
Thank you, Ryan. Really appreciate that informative presentation, and we do have questions coming in. Plenty of time, and I encourage those of you that haven't asked a question yet to go ahead and get it in. We'll get to as many as we can, and we'll start with the couple that came in early. So Ryan, one question, and I believe you addressed this later on in the presentation, but maybe we can summarize how sodium azide reacts with copper, if and how that happens. So if you can touch on that some more.
The reaction is just a chemical reaction between the copper and the azide, and the result is copper azide. It's just the chemistry behind the material being a, like I had said earlier, a strong nucleophile. So its readiness to display suitable leaving groups. Really, that reaction between the sodium, the azide, the nitrogen part of the azide, displaces the sodium, and that the nitrogen component reacts with the copper to create a copper azide.
Okay, thanks for clarifying that. And another one that came in early, I think you may have touched on this too, from Sarah. She wants to know what quantity of sodium azide is needed to initiate an explosion.
There have been a few studies on this, but really, if it's pure sodium azide, really any quantity will be energetic. If you heat it up, you're going to have a rapid release of nitrogen gas. Like I said about if you want to, I guess, visualize, 130 grams is what it takes to inflate an airbag. And that's a pretty violent explosion. So if you pull that back, you know, and you have just maybe 50 to 70 grams, you're going to have about half a reaction of airbag inflation. So any amount can be energetic. The more that you have, the more it's going to be for a reaction.
Right. When it comes to storing, yeah, no, that's good, thank you. And when it comes to storing sodium azide, Ian wants to know if storage in glass containers is a concern.
No.
No, that's a simple.
I wouldn't think. Yeah, I wouldn't think glass containers isn't really a concern. You might have the sodium might react with the glass a little bit, but that's a safe way for storage. Plastic is recommended just because you won't break it, but glass, you shouldn't have a problem.
What is not recommended? Is there a type of container you wouldn't recommend?
Metal, for sure.
Oh, there you go.
Even a 55-gallon drum has, you know, that's not something that you're going to want to store sodium azide in. You have the potential on the threads of, say, where you open it up with a bung. There's been issues of people having reactions there with the copper.
Great. And Jonathan is curious how he should dispose of his empty sodium azide chemicals. Should he rinse, or should this be lab packed?
I'm sorry, you cut out there a second, James.
Okay.
Can you repeat the question?
Yeah. How should he dispose of his empty sodium azide chemicals? Should they be rinsed or lab packed?
Empty containers?
Empty containers. Yeah, empty sodium azide containers.
Well, since it is a P-listed waste, what you would want to do is triple rinse and collect that rinsate. So you would do 100% filling of that volume, dump the rinsate into a bigger container, do that 3 times, and then you would have to dispose of that rinsate as sodium azide contaminated waste, which would, I believe, still be, it still would have to get lab packed in that case.
Okay. Good. I think that answers that question. And you just mentioned that, you know, we don't want to store in metal containers. Now we're getting pretty specific. Lisa wants to know, are stainless steel fittings a problem?
Stainless steel is really not that much of a problem, but you don't know the exact components of that stainless all the time.
So could there still be minimal risk associated?
Yeah, if there's any sort of transition, if there's any sort of lead, zinc, brass, anything like that within the metal, there's still a hazard.
So your recommendation, know exactly what the components of that stainless steel are if you're going to use it, just to be safe.
Correct.
Great. And a question from Keith. Is there any risk associated with storing azide solutions in plastic jugs for off-site disposal?
No, that's actually how I would recommend storing those solutions.
Okay. And he's saying anything from 0.1 to 2%. As far as how much?
That's definitely the recommended route for storage and disposal.
Okay. Good.
The only risk is obviously contact. Just wear your personal protective equipment.
And a question from Paula. Is storing very old, we're talking over 15 years, a virgin sodium azide okay? What would you recommend there?
Well, I would recommend disposing of it with that amount of time at that age. It's probably getting more and more unstable. It is shock sensitive, and over time, if it's drying out, I guess it could potentially become more of a hazard. So I would, if it's not being used, I would recommend thinking about getting rid of that.
Okay. And what would, as far as best practices for eliminating or getting rid of it, what would you recommend there?
I would recommend having a professional come and look at where it's stored. Just take a look at the container integrity, and I would have maybe Triumvirate come and look at it, because something that old, even if it's in a plastic container or something, even that plastic can start to fade over time and even dry out and become brittle. Mm-hmm. So might want to have a professional opinion take a look at that.
Okay, and Keith is back to us with another question. Is lab packing azide solutions in a stabilizer added or pre-treatment required by the waste hauler?
The waste hauler will generally, if I'm understanding this right, if we have a solution that's already in solution, it's shipped as is in solution. If it's in powdered form, the hauler will generally wet it or put it in a container of water just to stabilize it during shipment, and that would be included by the waste hauler. If I'm understanding that correct.
Yeah, and so we'll read it another way. In lab packing azide solutions is a stabilizer added or pre-treatment required by the waste hauler. So I think you got that right.
Yeah. Yep. We stabilize it with water, actually.
Great. And we've got a few more questions. Oh, they're still coming in. So we've got, I think we'll wrap things up in about 10 minutes. There's still time, so get your question in.
Yep.
Question from Carol. Should institutions conduct any survey, especially in clinical spaces, for this issue?
Absolutely. I would highly recommend that. And keep in mind that plumbing systems, they're only visible in the lab at a certain extent. Once something hits a wall, something could completely change. Mm-hmm. We've done these assessments for people just to see their clinical areas, to see if there's any associated hazard. An inspection is definitely recommended, and it's something we can help you with.
Great. And Tammy wants to know, how about use of 0.02% in heated bath, small volumes? Is that okay in room or only in the hood?
I would recommend doing that in the hood.
Okay.
It is a small solution, but you know, doing anything with that sort of toxic material would be recommended within a hood.
Even at that amount, you'd recommend just
Correct.
be cautious. Okay. Good. Okay, so we got this one from Carol. Here we go. Do most newly sold hematology automation machines use sodium azide?
Surprisingly, yes.
Oh.
And they won't allow anything else. It's what their system utilizes. I've had clients call manufacturers and ask for an alternative solution, and they just won't provide that. So it is still very common.
And Sarah, we'll take a couple more. Sarah wants to know what specific tasks are performed to inspect the lab. So we talked a little bit about, you know, the surveys and the assessments. What does that mean exactly?
So an inspection would consist of finding hematology equipment that utilize the sodium azide, and then inspecting not only the plumbing that was receiving the waste. That is the main concern, would be the plumbing system that is receiving any sort of waste, but you also need to look around that equipment for anything that has copper, brass, zinc, tin, anything like that that may come in contact with solution. If that machine has a slight drip, or if reagent waste is splashing in an area. That's how one of these incidents happened. It was a copper wire that wasn't even part of the plumbing. But it's just a thorough inspection from the machine to the plumbing, and even from that plumbing to your wastewater system. So it's kind of an inspection of the whole process of how that waste is coming from that machine through the plumbing system to your wastewater system, and then an inspection of management practices of the material, and then of the equipment and supplies surrounding that material.
So based on your response, I think the answer to the next question is yes, but Renee asks, can we sample our plumbing waste lines for sodium or metal azide?
The answer to that is actually no, and the reason why is, I had alluded to it earlier, but the buildup of this stuff occurs in interstitial spaces between, most of the time, between fittings, the threads of fittings and the plumbing. That's an area that receives the water quickly and dries out quickly. So that's where a lot of these reactions happen, and it's impossible to get a wipe sample into those interstitial spaces. You can wipe sample the plumbing, but it's not going to give you a definitive answer of what lies in those spaces.
There you go.
It's a difficult thing to do, sample.
Well, good question, Renee. And let's take one more, Ryan. Last question for today. And there might have been a couple pretty specific ones that we'll follow up on later. And our final question is, our plumbing is PVC and non-metal, but what about the sewer lines outside of our facility?
That's a great question. Once that waste goes through PVC, non-metal, and hits sewer, you're talking about a very large volume. And that volume is really enough to prevent any sort of reaction, because the volume is just so high that it's really not likely that anything's going to be involved with large sewer systems.
Well, thank you, Ryan. I think you'll agree these are some really good questions, and we'd love to continue the conversation with you. So in a couple of slides, we'll be sharing Ryan's information, so feel free to reach out.
There we go.
One question that came up a couple of times, I think some people joined late, is whether you'll get access to the slides, and you will. So you'll receive that in an email tomorrow along with the recording of today's webinar. So I wanted to wrap up here with this slide. You have Ryan's email address, also the phone number for Triumvirate. As Ryan indicated, this is work that we can help with in eliminating this risk, and he mentioned some remediation projects that Ryan has been a part of in the past. So give us a call, and there's a link on this webinar screen as well. Follow that link. As a thank you for attending, we're offering a free assessment, which Ryan touched on. So fill out that form, and we'll be in touch to talk about your specific situation and the importance of these assessments in revealing potential hazards as they relate to sodium azide and others. So that concludes today's webinar. We appreciate you joining, for participating, and asking some great questions, and we hope that you took away some points that will help you address any risks that may be present in your facility. Ryan, anything else to add before we close down?
No, thank you everybody who attended, and I look forward to hearing from you. If you have any questions, just let me know. Feel free, my email's right there, and I'll try to get back to you as soon as I can.
All right, thank you all. Have a great rest of the day. We appreciate it. Take care.